one of the most asked questions of all time, I guess, according to my statistics, is how will the earth end? And some people say by fire, some people say due to ice, as stated so well and precisely in Robert Frost's poem Ice and Fire. But not many know that there's a mathematical way of ending the world. Okay, so here it goes. Legends say that Lord Brahma, he made three towers, thin towers, and he made an arrangement like this. These are the three towers. He put 64 discs. I couldn't draw 64 because it won't fit. Okay, so but stated over here 64 discs, and he arranged them like this in decreasing order of their size, or increasing order from top, decreasing from bottom. And he gave them to a few trustworthy priests. And he said that if the priests can arrange all these are golden discs, by the way, as you can see from the color of my pen. Well, I don't know what you call this, but of my pen. That when the priests they transfer all these discs from tower 1 to tower 3, the world will end. And legend has it that they're still working on it. So we might die anytime soon. Keep thinking about that. And that's how the world will end. Hello, welcome back to another video. Okay, in the introduction, I might have scared a few people amongst you, and maybe a few who already knew about this. Well, they knew about this. I can't say much about them. Anyway, so I'm here to burst your bubble and tell you, don't worry, we're not going to die right now. There's still some time left. Okay, so how do we know there's time left? Well, the only way is if you can figure out how much time they're going to take to actually arrange all of that. All these three towers and 64 discs. These are discs, if it wasn't apparent already. Okay, this is a puzzle. And one thing while solving mathematical puzzles is you never start with the big examples. You take small examples and keep finding out a pattern, and eventually you get the big answers. And okay, so there's another puzzle similar to this called the Towers of Hanoi. Instead of 64 discs, it has 8 discs. And that is comparatively easier to figure out than 64 discs. Obviously, that's a square difference. Okay, so I'm going to try to find out a pattern for each one of this. So I'm just going to call it T sub Tn. It's the number of moves it takes to get to the third tower. T is for tower. Okay, so let's see what is T1. Well, if you have one disk, it takes one move to get to this spot. So T1 is 1. Okay. And I'm going to remove these symbols because I don't like to draw a lot, and I'll give it a much better notation. So, tower 1, tower 2, and tower 3. And, T2 is equal to, according to my new notation, this is 2, this is 1. The greater one, 1. And the bigger one has to come. The bigger one has to always be below the lower one. Like 2 always has to be below 1. Otherwise, it will crash and that will destroy the puzzle. And like mathematicians, we don't like to destroy puzzles because we have to solve them. Okay, so we have to get 1, 2, 3. How do we do this? Well, the obvious answer which you can see is get 1 to 2, get 2 to 3, and get 1 to 3. And how many steps is that? 1, 2, and 3. So T of 2 is 3. And this is going to be a bit big comparatively. So if we have 3, 2, 1, then what do? Okay, 1, 2, 3. Bear with me, this might take some space issues. Okay, get 1 to 2, get 2 to 3. Wait, no, I'll do it in a proper order to actually see the moves. Get 1 to 2. I'll put that over here because we have some space issue. 3, 2, 1. 1, 2, 3. Okay, get 2 over here. Oh, I see the problem. No, I don't. Okay, then going to the new 3, 1, 2, 1. Okay, I'm not going to write this. Apparent. Which tower is which? Then, well, what do we want to do? We want to move a 3 to a 3. So, we need to make space. So, we put 1 on top of 2. 3, 2, 1. And that's valid because 2 is greater than 1. Alright. Ta-da, ta-da. And one step, 2 step, 3 steps already. Okay, what do we need to do now? We want to do something. Oh no, I'm confused now. Just 1 second. So, well, it went through a bit of detour. Okay, so now here's what you will do. You will get 3. You will move 3 from its original position because you want to occupy you don't want the 3 to be stuck in one place. You need to move it somewhere. Okay, so now you have 3, 2, and 1. Move 1 over here first. That's what you're supposed to do. Okay, and then due to lack of space, I'll move in the uncomfortable no man's land. And 1, 3, and 2. And I'm going to do 2 steps in one shot. 2 steps in one shot. And move 2 over here, move 1 over here. Okay, there's one slight problem that all of them are, instead of at tower 3, they're at tower 2. But if you replace 3 by 2, you realize that they're the same problem. If you put 3 and 2 over here, that doesn't make a difference. So you can just interchange the towers in a particular way to get the answer. And over here, we're not looking at how to get it to tower 3 or tower 2. We're looking at number of steps. And by my logic over here, they should be the same steps. So either get it to tower 3 or tower 2, it doesn't matter. False. It's going to be the same thing. Now let's go on the steps. Step number 1, 2, 3, 4, 5, 6, and 7. So that's 7 steps. Alright, I'll erase all of this. Alright, and T of 3 is equal to 7. Okay. Okay, it's hard to miss a pattern. Like, I know what everyone's thinking. T of n is equal to 2 to the power n minus 1. That is what everybody's thinking. And as it turns out, you people are right. But we don't know if this is correct. This is based on 3 random numbers in a given order. It could quite literally be anything. This is the most obvious answer, but before we proceed, we need to prove it, because that's what mathematicians do. We prove things which others cannot. Just keep it over here on top. Is equal to 2 to the power n minus 1 and question mark. Okay, now how do we prove it? Towers of Hanoi is actually one of the best recursion problems, probably right after Fibonacci numbers. So, well, I'll try to do a general case. Suppose you have n minus 1 dot 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 up until 1. You have n terms here, blank, blank. Now, suppose you know for t of n minus 1 and you want to find t of n in terms of t of n t of n minus 1. Well, how do you do that? Well, this is a simple pattern swapping thing. Just try to follow me. Okay, so how do we do that? Well, first you take all these n minus 1, put them over here. Ignore this n and move all n minus 1 disk to position 2, which I've shown you is the same as moving into position 3. So now you have all of these in the same order over here. So that will basically give 1, 2, 3, n and n minus 1 till 1. Now, we need n to be in tower 3. So, we move n to tower 3. Okay, I'll just write over here. This is t n minus 1 steps. This is 1 step. And now, n minus 1 to 1. And we have 1 lone n over there. Now, we need to move everything back to tower 3. So, we get all of these over here, which will take t n minus 1 steps. And how many steps is that? T of n minus 1 plus 1 plus t of n minus 1. Well, we can see t of n is equal to 2t of n minus 1 plus 1. Now, this is correct. We don't assume anything like we assumed over here. But we need to prove that these two are equivalent statements. So let's solve. Well, t of n is equal to 2t n minus 1 plus 1. How do we solve this? Okay, we're going to use one thing which a lot of people, a lot of basic mathematicians might feel stupid or may not enjoy it much, but it's one of the most useful things. It's called induction. That's perfect because right now we have an equation which we have to prove, which we know is true. We have what we theorize to be an answer. We just need to test if it's true or not. Let's put the values and see if it's true or not. Okay, what is this? 2 to the power n minus 1 is equal to question mark, or we're not sure this is equal. 2 into 2 to the power n minus 1 minus 1 plus 1. Okay, so 2 to the power n minus 1 equal to question mark 2 into 2 to the power n minus 1 minus 2 plus 1, and minus 2 plus 1 is minus 1 minus 1 plus 1 is equal, get this to the side, minus 1 plus 1 is equal to 0, and 2 to the power n is equal to no question mark 2 to the power n, because 0 is equal to 0, this we know. If you have 0 oranges, then you have 0 oranges, and that's the proof of 0 is equal to 0. Really true. So we can write t of n is equal to 2 to the power n minus 1. Now Towers of Hanoi has t to the power 8 moves, which is 2 to the power 8 minus 1. 2 to the power 8 is 256 minus 1, which is 255. So 8 goes to 255 moves. And on the original apocalyptic problem, t of 64 is 2 to the power 64 minus 1, which is enough to give a lot of computers a nightmare. And that has a lot of, and if you assume a priest moves 1 block per second, which is an almost impossible rate, that'll take him almost a million more years to actually achieve this. And that is if he gets each block in the correct position, knowing the maths of how this works. So, my friends, you're safe. God bless the world.